We're going to go ahead and solve this using the Feynman technique. And that tells us that we're going to create an equation, f of alpha, and that's going to be equal to the integral 0 to 1. And look what we're going to change. We're going to change x to the power of alpha plus 1 over natural log of x dx. Now, alpha is just a variable here that you can write as a k or a b, whatever you'd like. And what this technique tells us is that we're going to go ahead and take the derivative of this. And on the right side, we're going to take the partial derivative in terms of alpha. So because we're going to take the partial derivative, this ln of x is just a constant that's on the bottom. So really, we just got to worry about taking the partial derivative of the top. Now, when we take the derivative of the top, we're focused on the x to the power of alpha. We're going to use that exponential rule for the derivative. So this is going to become I took the derivative of x to the power of alpha. The derivative of 1 was 0, so that goes away. And now we have this integral, and you can see that the ln's cancel out. So now we're left with this integral. And now to simplify this, we're actually going to take the integral of the right side, and now it's going to be in terms of x. So now we treat the alpha like a constant. But then don't forget we're taking the definite integral, so we have to evaluate this from 0 to 1. So as you can see, f prime of alpha is equal to 1 over alpha plus 1. You could think of f prime of alpha as d of f over d alpha is equal to 1 over alpha plus 1. And I can use separation of variables to solve for f. And now we can go ahead and integrate both sides in respect of their variables. On the left side, we just get f of alpha. And on the right side, using u substitution, we get natural log of absolute value of alpha plus 1. And for the Feynman technique, we're going to go ahead and disregard the plus c. Now, don't forget that this is our answer, f of alpha, which we had made equal to the integral of 0 to 1, x of alpha plus 1 over natural log x dx. And we know that this is going to be equal to the natural log of alpha plus 1. Let's look at the original function. The original function gave us that alpha was equal to 2. So now we just plug in the value of alpha at the very end. And that tells us that this original integral that we were trying to solve is equal to the natural log of 3. Pretty neat, huh?